Hi, welcome to the Chico Math Lab and differential equation problem solving session. So today, this is the differential equation we're going to solve. So it's y prime equal to sine y minus t. It's a very simple differential equation, but the way to solve it might require some um, do a substitution here because you will see the 1 minus t, sine 1 minus t is not linear. So we can have some strategy to do some substitution to make the equation can be do the variable separation, or we can change it to like a linear form in a certain way. All right, so let's take a look for this ones here. Let's go ahead and get a start. Like I always do, I like to change the y prime to the dy dt. So this is the sine 1 minus t, see here. So we know the sine 1 minus t, this is the inside here. So it's kind of like to prevent us to do the variable separations, right? So now let's try to do a substitution. So I substitute the u is equal to y minus t, okay? Then the du dt going to be equal to the dy dt plus minus 1, correct? All right, so now I will replace the dy dt is equal to move the 1 over, so it will be a du dt plus 1. Then I will put this one back to here. All right, so the dy dt is equal to the du over dt plus 1, right? Is equal to what? Is equal to sine u here. Okay, because 1 minus t. So then you can see this is du dt is equal to the sine u minus 1. Well, that's pretty good because now if you take a look, my right-hand side is only a function of the u, and I have du here. So I know, okay, that's great. So I can use variable separations, right? So move all the u in the one side. So the left-hand side will be sine u minus 1 equal to what? Equal to dt. Right? And then we say, okay, this is after you do the variable separation, then that will pretty easy. We can just integrate both sides here. Okay, so now this is the next step is to try to kind of test your calculus 2 to see how is your integration. Sine u minus 1. So what I need to do is here, I think I will do this. I will do sine u minus 1 times sine u plus 1. So here this was sine u plus 1 du. This part is easy. Let me just write here. This part, all right, so we will write it out. This is just a t plus c. Later we will substitute back. All right, so this is t plus c. Okay, so now this one's here is this. Okay, so now here you will see here this is a sine square u minus 1, and this is a sine u plus 1 du. And then I know the sine square, so Pythagorean theory for the trig identity, right? Sine square plus cosine square equal to 1. So in here, the sine square u minus 1 will just be what? Is negative cosine square u, sine u plus 1 du. So, right? So now the reason why, you might ask me, say, hey, why in here, you do the times this. The reason why I times this because I want to use the sine cosine Pythagorean identity. So then I will be able to have only one here, right? So one term. The one term here I be able to separate this into because the denominator is one term and the numerator is two. So I will be able to separate this one as a negative sine u cosine square u du, then minus cosine 1 over cosine square u du. All right. So for this ones here, okay, so this ones here, then I would need to do a u sub again, right? So I will do a u sub. So here I will set u star is equal to the cosine u, okay? So then the du star is equal to the negative sine u du. So I can put it back here. So this one I will keep it in the red. So this will be, so what this will be is 1 over, right? So negative sine u du, negative sine u du is here. Did you see that? So this one's here. Okay. So this one's here is negative, right? Sine u du, negative sine u du. So it's du star. Okay. So now this one's here is going to be 1 over u star the square, right? du star. Okay. Then this one's here, this will be negative 2 plus 1 u, the negative u star, negative 2 plus 1. So what is this one? Is negative u star, right? Negative 2 plus 1 is 1, right? So it's a negative u star. Now I substitute back. What is my u star? It's cosine, right? So now I will be able to put it back to, so it's a negative 1 over cosine u. All right, so it's 1 over cosine u. Okay, so this is this side. Now this side here, let me take a look at this one. Okay, so let me use a different color here. Okay, so for this ones here, I will do my integration here. So this is integrate cosine square. So what is cosine square? 1 over cosine square is the secant squares, right? So this is giving me let me use the same color so we know which one I'm working on. So here, this is the secant square u, right? So this is the secant square u du. All right, so the secant square, we know what is the secant square? That is pretty simple. What is that? It's a tangent, right? So it's a tangent u. Okay, so it's a tangent u. So finally, I got this, so after two integration here, so I have the negative 1 over cosine u. So it's this one you can change it to the negative secant u also. So it's going to be negative the secant u and plus minus. So here, right? So it's a tangent u, but I have a negative here, so it's a minus tangent u. Okay, so what is my right-hand side? Is a t plus c, right? So it's a t plus c, so it's equal to t plus c. Now I will substitute to the negative secant u is what? Y minus t here, right? Minus tangent y minus t equal to the t plus c. Now I have 1, 0 is equal to 0. Okay, so now let's try to put the numbers here. Let me see here. Let me give a different color. Okay, so y0. So this is 0 minus 0. This is 0 minus 0. So secant 0 is what? negative 1, right? So this second zero is 1. So here's a negative 1. Tangent 0 is 0. So negative 1 is equal to t equal to 0, right? So it's equal to c. So c is equal to negative 1. So finally, I have our final answer. So the final answer will be negative second y minus t minus 10 y minus t equal to the t minus 1 here. Okay, so this is the final answer. So this problem is not too hard. So the only things here, we need to, because this is nonlinear to start with, so you might need to think about the you know the the substitution. So the key things here is this is substitutions, right? U equal to the yt's here. Then you separate the whole differential equations and become the separate variables here. Then your equation will become pretty easy. You just integrate both sides. All right, that's it. And I like this problem. It's a very it's not a hard problem, but we learn something different methodologies, right? It's a substitution. I hope this will help you with your homework. And okay, so guess we talk to you later for our next work session here. All right, bye. Have a good day. Bye bye.